Hello, everyone. Good morning, good afternoon, or good evening, depending on where you're logging in from. I am Andy Thorai. Yes, that is Thorai with an AI. I know, the irony. I'm the founder and principal at the Field CTO. Where we do a lot of emerging technology work, AI and ML, and cloud in particular. You can check out a lot of our work on thefieldcto.com, or you can follow me on LinkedIn or on Twitter at Andy Thorai. So today's topic is RDA, robotic data automation, and how it improves AI ops. However, the general topic of this discussion covers a data pipeline and data ops for AI ML model creations as well, not just to AI ops. There are some specific nuances in those use cases which I can discuss at a later time. So before we get in there, I want to clarify something. There's a lot of confusion and there's a lot of FUD by vendors as well on what is observability versus AI ops versus monitoring. I wrote a Forbes article on this topic recently. You can find that out posted in Forbes and or on my website at thefieldcto.com as well. Check it out. In a nutshell, monitoring is about instrumentation and proper data collection. Primarily time series metrics that measure the state of something, whether it's an application level metrics such as RED. In general, monitoring is about understanding if things are working properly. Observability, known as O11Y in short, on the other hand, involves collecting the so-called golden telemetry, logs, metrics, and traces at a minimum, maybe even events and notification alerts on top of it. The bottom line, you should be able to figure out everything about your system using those external outputs. Not only what goes wrong, when it goes wrong, but also why it went wrong and what went wrong. And more importantly, either a suggestion on what needs to be done to fix it. If properly instrumented, the high-level observability systems can remediate the incident with very little or no human intervention. AI ops is about applying AI and ML to those metrics and telemetry data to figure out what, when, and how, etc. There are more use cases to AI ops. I strongly recommend that you read the blog and that particular blog and that I was talking about earlier, and also a couple of more blogs that are on my website on the topic. And of course, there are other fine articles on the topic as well if you Google it. So I want to talk about this before we get in deeper into the discussion. I just wrote this article about a couple of days ago, matter of fact, based on my conversations with the enterprise CXO level executives and based on my number of years of experience in the field. Almost every AI ML project, AI ops projects included, failed because of one issue. Want to take a guess what it is? Data, of course. To be more specific, data pipeline problem. Almost every single large enterprise has a data problem. Honestly, most of them have a problem because they have too much data. I'll outline some of the data specific issues and how automating the data pipeline or RDA, which stands for Robotic Data Automation, can solve the problem. So I'll discuss some of those issues about the data issues in particular, in no particular order, that I see large enterprises and make some recommendations in the end. I hope I'll have time for that. So one of the major pain points for the enterprises would be data collection and the volume of data actually. So given that almost every large enterprise is moving to the cloud native microservices based architecture, it looked like this. This is actually a Netflix microservice architecture that is published in Medium. Check that out. It talks about in more detail on how they architected the solution, which is a fascinating read. But simply put, Netflix uses upwards of 700 microservices to deliver the total digital experience to you. Uber, as a case study on CNCF as well, which claims they have upwards of 4,000 microservices. Imagine a complex container Kubernetes-based microservices architecture that looks like this. And the matter of fact is that both Netflix and Uber, they claim they push out thousands of changes to their microservices on a daily basis. And if you ever read the famous book by Gene Kim called the Visible Ops Handbook, you will know that 80% of the unplanned outages are cost changes. So changes to either infrastructure or application itself. Means you have no option to instrument everything and monitor and observe everything. This process need to be automated, such as every container, every microservice that gets dropped will have to come with instrumentation for data collection. The only way to properly integrate with all of them and automatically instrument them, automatically collect the data and get the data in right places can be done only by automating this entire data pipeline. In other words, RDA. Otherwise, it's going to be extremely difficult. And the second item I want to talk about is data integration. There's this difficult task of integration with data sources, of course. Another time-consuming, very expensive task. A lot of times, you need to bring professional expertise to integrate data producers into the systems. So mostly this is manual. SIs and consulting companies make big bucks on this. Not only initial integration is an issue, but if it is done through coding, maintenance of that code becomes very difficult as well as you move along. Anytime where a system on either side changes, it's a problem. One way to eliminate is if the data producers and data consumers are API enabled. It allows for somewhat easier integration, but it's still very involved, a very time-consuming task, especially because the input is a combination of structured, unstructured, and semi-structured messy data. So if done properly, for example, the observability vendors of the logs, metrics, and traces, whether searching the event, filtering the events, all of those data integration combinations can be somewhat automated in my mind. If it's done properly, the RDA should be able to reduce, if not eliminate, a lot of this data integration task, which is another item I'll make a recommendation in the end. And the third issue I see with the data pipeline issues is about data preparation itself. I'm not sure if many of you realize this, but data preparation is not an easy task. On an average, about 80% of the data scientist's job is spent on preparing the data. Raw data in its inherent nature is very dirty. At least about 20% of the raw data is said to be dirty. Dirty data obviously means it can have duplicate data, missing information, inaccurate information, incorrect information, or even biased information, which we'll talk about in the next slide. Your AI and ML model depends on your data. If your data is not properly prepared, it'll skew your model. If the model is wrong, then the insights, decisions, and the recommendation will be wrong. AI is based on data for most part. I actually wrote a piece on this in Forbes about a year ago. Why infusing AI into IT operations is more about the data than AI itself. So where I talk about these issues in more detail. So the bottom line is, if you don't spend enough time preparing your data, it'll result in what I call as a garbage in, garbage out situation. So this is actually an area where RDA can help a lot, which I'll discuss later in detail. On the next area where I see a lot of issues is what I call it as a data bias or cognitive bias based on data. So we as humans, in the past few years, have started to deal with this item, avoiding the bias. There are about 180 human biases that have been identified and classified, and human processes and procedures are in place to mitigate them. I actually wrote a piece on that about 2 years ago, also on my website, published at AI Trends on aitrends.com. Unfortunately, many of them, the biases, the human biases, are making its way into the AI design and into the raw data. Strangely enough, companies are willing to trust the mathematical models because they assume AI will eliminate human bias. However, those models can also introduce a set of biases if it goes unchecked. The number one area that need to be addressed is to automate the data cleaning to eliminate bias. This is an easy task for RDAs and can easily handle this. Eliminating bias from the data sets, that is. If your model or algorithm is based on biased data, then your decision will be biased. The only way to eliminate this problem would be to analyze the input data for inequalities, bias, and other negative information to make fair decisions. And the models need to be updated on a constant basis too. And the data need to be cleansed as it comes to it. The only way to achieve that will, it's RDA. So we talked about data being an issue. Data is the new oil, as they say. Similar to raw oil, it's also dangerous if you try to use it in its raw format. Imagine the discovery, exploration, extraction, refining, transportation process, the oil that goes through before it reaches your gas stations. Much the same way, data need to be refined before it can be used. Some of the other issues that we haven't discussed in the past few slides is the other data labeling and classification, data classification issues. Most people think as soon as you get some form of data, AI knows what to do with that and how to use that and where. Boy, are they wrong. First, data needs to be identified, classified, cleansed, and properly labeled before the AI and ML systems can even touch it, let alone get insights from it. This mundane process of data wrangling is a big issue for a lot of enterprises. They still quite haven't figured it out on how to automate this process. If you disagree with me, just check out how big Amazon's mechanical Turk business is and all the things they do for this data pipeline process manually. It's a big process, costly, time-consuming, error-prone, and very slow. So obviously, if you don't automate this, this is going to affect our AI and outcomes. So data issues in general, we can classify the AI ML related data issues into 3 buckets. First, obviously, it's the data integration issues to get the data from the source, from a data silos where it's produced, which we talked about. The second is to cleanse the data before it can be used. And the last one is data enrichment or tagging. After you refine the data, it's still not ready to be used. That's where the labeling, classification, grouping, etc. comes into place. Also, data enrichment and data correlation in general need to be part of this equation as well. Data enrichment is about taking the raw cryptic data and add information to it so it can be helpful to support teams in case of support issues, or data scientists or decision makers, depending on what they're looking at. Bots actually can do that very easily. The manual process can be very expensive. Lastly, data correlation is a pretty big topic to cover here, but in a nutshell, don't just take the data, but take all the related information with it. For example, with the IT operations theme, what else happened at the time? Any other events that triggered it? Any other data points that can be added to the actual data itself to make it more rich. So we talked about the data issues that is a problem for AI, ML modeling and stuff. So before we go there, obviously, I wanted to talk about how RDA can solve these issues. But before we go there, the first thing we need to do is we got to define what a robot is. So we talked about data issues so far, right? So I want to spend a few minutes in talking about what a robot is and what RDA is. So that's an interesting question. What is AI? And what is robot? And what is self-awareness? At what point you can decide it's good or bad for the humans? How do you define it? In my point of view, a robot is either a piece of hardware or software or both that's capable of performing a variety of human tasks in an automated way, much faster than a human can. Some easy and some difficult tasks. They all should have the ability to learn, adapt, self-sustain, and knowledgeable. Obviously, there's a school of thought. They are suggesting the robots should learn things, not in a supervised manner, but also in a semi-supervised or unsupervised. That's not a problem as long as the unsupervised portion falls within the bounds of a controlled nature, a human control very specifically. It's when the robots become self-aware when we get in trouble. But even if it gets self-aware, who decides if they are right or wrong? For example, James Cameron would tell you that they will become terminators and end all human life forms. One can argue that the self-aware robot can also be like my favorite, Johnny number 5. In their mind, they both think they're right, as they do what they think is right. They learn, and therefore they decide what they think is right. If it works for us, we celebrate. If not, we will make Arnold a celebrity. I know that's so deep and such a debatable topic, but that's not what this webinar is about. By the way, just to be clear, robots are very commonly called bots in the software industry. So when you hear the name like chatbots, we are talking about software version of robots. If you ever tried customer support with Uber, Lyft, etc., you will know what I'm talking about. Even CNN has what they call it as a news bot. So that's what is a bot in my view. And then we need to define what the difference is between RPA and RDA. Let's talk about the two variations of the robotic applications that are very commonly used in the software industry. One is RPA, which is known as robotic process automation, and another still an infant term, but gaining popularity quickly is a term called RDA, or robotic data automation. They are both somewhat same yet very different. Stated in its simplest form, RPA is about automating user tasks, processes, and workflows. And RDA is about automating data tasks and data pipelines. So RPA was born about 10 years or so ago to solve human inefficiencies. To put it simply, RPA is all about automating something that's mundane task, boring yet time-consuming for humans to do what when done in volume. Essentially, the software that's self-learning observes humans doing certain tasks, such as filling forms, and by watching human behavior, it can eliminate the human behavior by thereby eliminating the need to have all of this done manually. So the form data fills, button clicks, mouse movements can all be captured by the software and transferred to an RPA wireframe, which will then translate them into code. Next time when the same forms need to be filled, the RPA will do the actual work in a much faster way. For a single form, it may not matter, but imagine an auto insurance company having to go through all the documents submitted by a client, validate all the form fills, request a better copy if it is not properly legible, or request additional documents if they don't satisfy what you're looking for. And imagine them have to do this for tens of thousands of their clients on a regular basis. and each of them have to, fill 10, 20 forms. It can quickly add up and overwhelm the human operators. Then comes the question of what is RDA? When you start using those robotic processes to solve data problems, then it becomes RDA, robotic data automation. They are somewhat similar yet different. While RPA automates the actual process workflow, RDA helps fixing the data pipeline issues. RDA is generally what I call it as a data ops automation framework with bot libraries, data management pipeline tools. Generally, it's automating the manual, cumbersome, expensive data pipeline processes with bots. This means you should be able to manipulate the data pipeline as needed using a low-code, no-code bots and have automatically integrate, collect, and use the data as needed. A properly implemented RDA should allow users to get to play with different models and change things on the fly. For example, you see a bunch of data sources in the left side here. By doing a low-code automation, by having the bots, you should be able to figure out what data to get where and how to enrich and do all of this data issues, what we talked about, and provide in a format that data scientists or end user will require by doing it automatically in a low-code manner, right? Because in the data economy, the models, data, and the value of data change in a matter of seconds, unlike the old computer economy. When it comes to data pipelines, especially, you have to operationalize the machine data at scale for AI operations. Then you have to automate them. There is no way you could do it manually. Obviously, this helps enterprises realize the value much faster. And when we're talking about a data task, the task can be either data collection, data integration, data validation, data cleanup, data normalization, metadata enrichment, data extraction from structured or unstructured data, can all be classified as the RDA operations. As we talked about earlier, data volume is not an issue with most of this organization. Most of them have enough data. It's getting the value out of this is a major issue. Most organizations think having too much data means they can get a lot of value from the data. Unfortunately, it doesn't work like that. Volume never equates to value when it comes to data. It's the quality of that data that matters. If you can figure out a way to automate most of this task, your ROI will be a lot quicker and time to market will be a lot faster. So I have a quick example here on data enrichment use case we talked about on the RDA. I think one of my co-speakers is going to talk about this in detail, but I just wanted to show you a sample of an RDA work here. This is actually a data enrichment sample, as I said. The input, as you can see, is very raw, not user-friendly, and not much information in it. But by using RDA or data bots, you could convert them by adding more information, relevant information, that is, it becomes a lot more usable. The output, as you can see, is a lot more information that's added by a bot. So that's just a quick example rather than talking about theoretically, right? So that brings us to my last slide on what do I generally recommend when I talk to customers on what to do with the RDA or what to automate in the data pipeline. The best recommendation I can give you is to automate everything that's possible. If you are engaging in the AI world, use AI to help you. Automate everything mundane, repeatable, measurable results, the boring work. Automate the data pipeline. See, DevOps brought a new coding culture and discipline to the compute or code-based industry. And using the data ops will bring the data discipline to the data economy. So in essence, data ops is the equivalent of DevOps for the compute economy, for the AI ML field. So all the so-called digital native companies have figured this out because they all thrive on data and they all have too much data. If any of them are successful, that means they have figured out how to handle their data pipeline properly. Just pick an example. Imagine Uber not being able to find or properly price your ride when and where you need it, or Airbnb pricing themselves unattractive against the competition, hotels that is, because they had a problem crunching the numbers. They would go out of business in one day. Bottom line, the recommendation if you want to become a data-driven company is to fix your data issues first. And thank you for spending a little bit of your valuable time with me. I am Andy Thurai. Yes, that is Thurai with an AI. You can follow me on the social handles. Thanks again, and good luck to all of you. With that, I will pass it on to my next speaker. Take care, you all. Bye.